A year on Earth is measured by one complete trip around the Sun. Seems simple enough, but there is a problem. The Earth doesn't travel in a path around the Sun that returns to its starting point. So how do we know when a year starts or ends? Well, one way, called a sidereal year, measures our orbit against the distant stars. As viewed from the Earth, our orbit causes the Sun to appear to move through the constellations of the zodiac on a path called the ecliptic. And when the Sun returns to its starting point, a sidereal year has passed. This motion is difficult to observe directly because the stars cannot be seen when the Sun is in the sky. However, if you look at the sky before each dawn, the annual motion is very noticeable. The last stars seen to rise are not always the same, and within a week or two, an upward shift can be noted. As an example, in July in the northern hemisphere, Orion cannot be seen in the dawn sky, but in August, it becomes easily visible. Measuring a year this way gives a period that is 365 days, 6 hours, 9 minutes, and 10 seconds long. Another possibility is to measure the year against the passing of the seasons. Because of the tilt of the Earth on its axis, the position of the Sun in the sky changes from day to day throughout the year. If we were to take a picture of the Sun at noon regularly throughout the year, we would see the Sun moving on this path called an analemma. On the days in its orbit when the Earth is at a maximum tilt towards or away from the Sun, the length of the daylight is at a maximum or a minimum. These days are called solstices, and the Sun will be at the top left or bottom right of the analemma. On the days when the Earth's tilt is perfectly sideways to the Sun, the day and night are equal in length. These are the equinoxes, and the Sun will be at this crossover position in the analemma. When the Sun goes from one vernal equinox to the next, a tropical year has passed. Measuring this way gives a year that is 365 days, 5 hours, 48 minutes, and 46 Gravitational effects of other planets cause the ellipse of our orbit to slowly spin around the Sun. It takes about 112,000 years for the ellipse to revolve once, relative to fixed stars. When considered together, the two forms of precession add, and it takes about 21,000 years for the solstice to go from aphelion to aphelion. The dates of the perihelion and the aphelion advance each year on this cycle, an average of 1 day per 58 years. The eccentricity of the Earth's orbit is a measure of how round or how oval the orbit shape is. Over thousands of years, the eccentricity of the Earth's orbit varies as a result of gravitational attractions among the planets, primarily Jupiter and Saturn. The orbital eccentricity cycles with a period of roughly 100,000 years. As the eccentricity of the orbit evolves, the semi-major axis of the orbital ellipse remains unchanged, so the length of the sidereal year remains unchanged. As the Earth travels in its orbit, the duration of seasons depends on the eccentricity of the orbit. When the orbital eccentricity is extreme, the seasons that occur on the far side of the orbit are substantially longer in duration. In addition to axial precession, there's the axial tilt, the angle the Earth's rotational axis makes with its orbital plane. It is currently about 23.4 degrees and is declining. This tilt varies from 22.1 degrees to 24.5 degrees. It makes one complete tilt